this one is cover crop plus their algae product. And if you really just truly see there's a very minimal observation is the biomass around this area is a lot of higher, denser than those areas. It's planted with the same type of cover crop. We have 14 cover crop varieties in each of these borders. And it's the tall grass to lagoon system. They have different function. They have different metabolism, and to be able to have the microbe community turn over the nutrient in a different way. That's our design. We want to increase that biodiversity, which is one of the principles of regenerative agriculture. I'm gonna turn over to Tucker and Meredith and let them introduce their product a little bit, and then just why they're doing this, what's their mission, how they wanted to help producer in this way, because we have a number of producer right here. It is good to hear somebody really cared about this on the better trajectory, right?
First, just want to express our appreciation to Yadi and Ryan and Dax and everybody involved with allowing us to participate. Our purpose in being here was really to get an opportunity to learn, does the algae have the same kind of positive benefits in soil and in plant here in this climate, in this bioregion that we've seen in the other places that we've worked? And so that's the purpose. I can tell you what we've learned in South Carolina and in 47 other states at this point is microalgae have a pretty profound effect in stimulating microbial activity. Microalgae are one of the first microorganisms to show up in soil when it's ready to rebuild itself, when it's been depleted. And what we've seen in all kinds of soil analysis, whether it's a Haney test or a phospholipid fatty acid test or a genomics test, is a growth of the microbial community, both in total count but species variety. We see the improved respiration, and this leads to all those positive consequences that come from improving your microbial health. It's the reason why you do the cover crops and the livestock. And so, our mission is to help the world transition away from chemically dependent agriculture. And we believe that the algae, it has a really useful place in that system. It's a transition tool. It works in conjunction with all of the other management practices and biologicals, and even precision chemical agronomy. And so, this is our contribution. We're able to grow this algae at a scale. I've got a bottle here, and we brought samples for everybody to take home. If you can't take one home because you flew, just talk to us and we'll get one shipped to you. It's 8 ounces to the acre. It's super easy to apply. And it's endlessly fascinating. I could talk about it. The positive consequences are so profound, and there's so many of them. So we just want to go slow, have some humility about it, learn in the different places. And so that's why we're here, and we're thrilled to meet all of you and enjoy learning from you and this energy. And when it comes to learning, Meredith's our lead on all of our research. She works with all of our farmers, universities, soil scientists, crop scientists, and so that's her role, and she can tell you more about the specific project and what we're after here.
As Yadi was saying, what we're seeing in the differences wherever we've used the algae, there's many improvements. There's as many improvements as there are systems that people are using them in. So when we're collecting data with our researchers and on-farm research, the anecdotal data is just as valuable and important to us. We're watching the animals. What are the animals doing? Where are they going? In a system like Yadi's, what he's seeing is increasing biomass, because the algae as an ancient ancestor of all plants and our ancestors, they're working collectively and ubiquitously, not picking and choosing, but we're taking the human element out of the control of the environment and allowing the algae to assist the microbial community to communicate and grow in diverse populations, and provide all the actions that they're providing down below around the root system, interacting with the plant the way they naturally were before we depleted these systems. So the way we're using it and the way we're describing it is as a transition tool. And the kinds of stories we get back from our growers are really amazing. Ryan asked us to add an emotional element to that. I was always told I was a good listener growing up, and I honestly believe that we're all just, hearing a call. and answering that call in all the work that we're doing and how we're interacting with our ancestors and the land and the water. I'll say another part about the water. We love the water. We treat the water and move the water in a very loving, intelligent design. And we take care of the life of the algae cells. You know, we care about them. And then we want them to come back out into a home. Chlorella vulgaris is who we work with, the strain that we work with, and they're located in arid regions and they're located in forest regions. So we're working with so many different partners. We just appreciate being able to come to a challenging area and to help assist. This is most exciting for us. When someone says, how should I use the algae? We usually say, take it to your toughest spot, you know? Let's go to the place where you're having the most problems, and we're helpers. So thank y'all. Thank you so much for having us out. This is a real high moment to be involved in a place where we're also going to gather and share our ideas and visions and carry those forward. That's such a huge part of it, and sharing the tears that will come from that, the stories and the music. We just appreciate all of it. So thank you. And the first things we started talking about is a biostimulant. The algae is a biostimulant. When it goes out to the field, it's interacting with the plants and with the microbiome below. So opening up the stomata, sunlight being used more, you know, these more efficient sun panels, making sugars below and exchanging with the community below. That's what we knew for the first couple of years. That's where we focused our conversation. But this study with James White, he was even fascinated by it. And the video that we share with y'all will show you how excited he is about this discovery too. The algae are actually acting as carriers. We call them the buses for bacterial species that are now entering into the root hairs on plants, they're endophytic. So they're carrying these useful bacteria back and forth within the plant systems. That's why we're seeing the root mass growth. They're working with fungal and bacterial species. So we'll see this balance happen in the fungal and bacterial species, which creates the savannas, which helps create, you know, agroforestry. This is our jam.
It's also filling the roots with chlorophyll, which is unique to live algae cells. This chlorophyte, it's a green algae, freshwater green algae, and you can see on their microscopy the roots that have algae, they're green.
Yeah, they're bright green.
And they're filled with chlorophyll, which is really cool.